Here is step 7 of 8 of our chapter 2 ladder review. In this video we are going to be looking at finding the zeros for this function, some of which are going to be real numbers and some of which that are going to be imaginary. So this will be fun. Alright, so the first question that we need to sort of answer here is being able to sketch a graph of this function. I'm not entirely sure what this looks like. I can figure out just by looking at some of the end behavior, but I think that we're going to want to use our graphing calculator to look at this. So here's what we're going to do. We are going to turn our graph calculator on, go to y equals, and I've actually already set up our equation into this calculator. You can see how that's all there. What I'm going to do is I'm going to hit graph, and what it does is it's graphed this thing for us. This isn't a super nice picture. It looks like our line is going through from the origin, looks like somewhere at -4 maybe, and over here somewhere between 0 and 1. So if I'm going to sketch that, I know that I'm going to be going sort of going through those points somewhere in here. And again, a sketch isn't going to be perfect. I think a lot of times we get caught up on wanting to make this perfect. Sketches are not going to be perfect, and that is okay. We're trying to get an idea of what this looks like. So to figure out where this thing might be, or where I'm crossing the y-axis, really we're going to want to change the window that we have here. So I'm going to go to my window, and I'm going to say, well, I really want my y minimum be lower. I want to be able to see this farther down, and it looks like this graph, I'll try and zoom in on this here, looks like this graph here that we're given goes down to 140. So I'm going to say, well, I don't know, maybe we want our minimum to be something like -135, and we'll hit graph again and see if we can get a picture of this. And actually that still doesn't look like that's enough to get the vertex, so maybe I'll go down a little bit farther. Window, well, let's just actually change that to 140 this time. Hit graph again. And now it looks like I'm seeing the whole picture for this bottom part of our graph here. And I'm going to hit the trace button, and that's going to allow me to move this cursor around. And it looks like the lowest y value we get is somewhere around -137. Again, this is just a sketch. I'm not worried about having the exact answer for the vertex here. I'm going to say it's about a little less than -137, and again about -2.5 for my x value. So I'm going to go down here about -2.5 down to about 137. I think we're somewhere in there. And then I think we can probably see what our y-intercept is too. If you hit the trace button on your calculator and then hit any number, and I want my y-intercept, so I'm going to say I want to know when x is equal to 0. So I'm literally just pressing 0, hitting enter, and that's going to give me this point that I want on the graph. So 0, -36. So on my graph, I think we're somewhere in here. So it looks like I've got some number or some graph that's going through and looking like this. And again, it's not perfect. This is just a sketch. We're going to really dive in here in a second to look more at these. So the next part, in part B, is to use synthetic division, and one of the things you're going to have to do to use synthetic division here is we're going to have to figure out what factor are we going to divide by, or what are we going to divide out, and we're going to need a 0 to be able to do that. And so going back to our graphing calculator, it looked like we had a couple places where we might have had some zeros. I'm going to change our window again just for a second so we can see this a little bit better. Now, just based on what I'm seeing here, I do think that there is probably a 0 at -4, but we really want to check to make sure that that's accurate. So what I'm going to do is say, let's trace, and I'm going to start going over to the left. I'm going to start trying to move over to the left where I can see my cursor. think once we get around -4, we'll see it. Oh, there it is. And what we can do, and this is really awesome, is we can press second and then the trace button, which goes to actually calculate. And I have this list of options of things that I can ask the calculator to calculate on that graph, and I want that 0 there. And then it asks us for the left bound, so I sort of want what's to the leftmost of this line, and that's going to be that point here, so I hit enter, and it says right bound, so I'm going to click to the right one, and that gives me, so it's actually going below, we can't really see it now, it's out of our window. I'm going to hit enter, and it says, do you want us to guess? Yes, we do. Enter again, and we do have this 0 at -4, 0. So now that we have that, I'm going to say, well, I have this 0 at -4, 0. I'm going to use synthetic division, and if you recall, using synthetic division, I'm going to take out this factor. I'm going to have sort of this little box set up. And what goes in this box is all of the coefficients, all the leading coefficients for my x's and my constant. So I'm going to have 2, 7, 14, 63, and -36. And if you recall how this works, I'm going to drop down this first number. I'm going to drop down this 2. 2 times -4 is -8. And then I'm going to add these two numbers now. So 7 minus 8, or put them together rather, 7 minus 8 is -1. -1 times -4 is +4. 14 plus 4 is 18. 18 times -4 is -72. 63 minus 72 is -9. -9 times -4 is +36, and that's nice. That's exactly what we're hoping for. And -36 plus 36 is 0. So what that is going to leave us with is, if I factor out this 0, this -4, what I'm left with is 2x cubed minus x squared, minus 1x squared, plus 18x minus 9. So I have that, and I've already factored out this 0 of -4, 0. So in part C, oh, sorry, you couldn't see that there. In C, they're asking us to factor this cubic function. And to do that, we are going to factor by grouping. So if I look at these two pieces and these two pieces I got, what I'm looking for is what do these two terms have in common that I can take out? What's the most I can take out of these two terms? And it looks like I can take out an x squared for those, so I'm going to take out an x squared. And on the inside, that's going to leave me with 2x and then -1. Over here, it looks like I can factor out a 9 from both of these. That's the greatest common factor. So take out a 9, and on the inside, what's left is 2x minus 1. And if you recall from our previous video where we did some of this factoring for a cubic function, whatever's in parentheses, these two pieces have to match, and that gives us one of our factors. Then these outside terms, or these coefficients, make up our second term. So that means to factor this, I've got x squared plus 9 times 2x minus 1. Now remember, that was just factoring the cubic part. We still have this other 0 of -4, so we're going to put that all together at the end. The work for our imaginary zeros, when I look at these two, this looks like I can get a 0 out of this pretty nicely. X squared plus 9, that is not going to give us real zeros. You can check that using the square root method, or if you want to use the quadratic formula, I am going to show it here. If I were to set this equal to 0, x squared plus 9 equals 0, what would happen? Well, I'd minus 9 on both sides, and that would give me x squared equals negative 9. And if I want to get x by itself, I would take the square root on both of these, add a little plus or minus, but I can't take the square root of a negative number to get a real solution. So this solution is going to have to be imaginary. If I think about what the square root of positive 9 is, that's 3. But because I have this negative here, this is going to be, our 0 is going to be at plus or minus 3i. And if you are unsure of why that's the case, it's because the square root of negative 9 is the same as the square root of 9 times the square root of negative 1. Square root of 9 is 3. And the square root of negative 1, we call that I, and that gives us 3i. So that's how we get that here. So we have plus or minus 3i. Then they want the factored form of this function altogether. So remember, in the beginning, we had this 0 at negative 4. So in factored form, that looks like x plus 4. Then we have times up front here, we have 2x minus 1. And our other piece was x squared plus 9. Last but not least, we want to know what are the zeros of this function. Well, the zeros, the first one we had was a negative 4. And again, this says zeros, not x-intercept, so it is okay for me to write just x equals here. Negative 4. Negative 4 would make this go to 0. 2x minus 1, if I set this equal to 0, I'd add the 1 to both sides and then divide by 2, giving me 1/2. And if you aren't sure about that, you can go ahead and use the zero product rule here to figure this out. Set all of these equal to 0, and you'll see what I'm talking about. And then last but not least, we have plus or minus 3i. And that makes sense because I have 4 zeros here, negative 4, 1/2, negative 3i, positive 3i, and the degree of the function we're talking about, this is a 4th degree polynomial.